February 15, 2013, Chelyabinsk, Russia. At 9:20 in the morning, the sky turned white. Brighter than the sun, in broad daylight, moving shadows appeared. Thousands of people walked toward their windows to look. 2 minutes and 20 seconds later, every window exploded inward. Nearly 1,500 people were injured. Almost none of them by the meteor itself. Every injury came from the glass. The object never even reached the ground. Before it became a disaster, it was just a rock in space. In space, objects like this are called meteoroids, or asteroids if they're large enough. The moment one hits the atmosphere, it becomes a meteor. If a piece survives and reaches the ground, it becomes a meteorite. The Chelyabinsk object was about 20 meters wide, roughly the size of a house. It entered the atmosphere at 19 kilometers per second. A rifle bullet travels roughly 1 kilometer per second. The International Space Station orbits at about 8 kilometers per second. The meteor was moving more than twice as fast as the space station. Now here's the thing most people get wrong about meteors. The popular idea is that they heat up because of friction. That's not what happens. Moving that fast, the meteor can't push the air out of its way. The air in front gets trapped and compressed violently. That compression raises the temperature to around 20,000 degrees. That's roughly 3 times hotter than the surface of the sun. At those temperatures, electrons get stripped away from the atoms in the air around the rock. The air itself turns into glowing, electrically charged gas. Scientists call this plasma. The sky around the meteor glows. Most of the light you see is not the rock burning. It's the superheated air wrapped around it. On the brightness scale astronomers use, the sun rates -26.7. The Chelyabinsk fireball rated -28. For a few seconds, that rock was brighter than the sun. As the rock burns, different minerals in it produce different colors in the sky. Sodium burns yellow. Magnesium burns blue-white. Nickel and iron push green tones through the glowing trail. The color of a fireball tells you what the rock is made of. Deeper in the atmosphere, the air gets denser as the rock descends. The force pressing against the front face of the rock keeps growing. At some altitude, that force exceeds what the rock can handle. The rock shatters. Each fragment exposes more surface area to the atmosphere. More surface area means more energy dumped into the air, much faster. When the shattering is catastrophic, the object explodes in the air. This is called an airburst. Chelyabinsk was an airburst. The explosion happened 30 kilometers above the ground. That's why there was no crater. All that energy went into the atmosphere as a pressure wave and heat. Siberia, June 30th, 1908. A rock estimated at 50 to 80 meters wide entered the atmosphere. No scientist anywhere on Earth had seen it coming. It exploded at roughly 8 kilometers above the ground. The energy released was between 10 and 15 megatons. That's roughly 1,000 times the bomb that destroyed Hiroshima. 2,000 square kilometers of Siberian forest was flattened. No crater formed. Eyewitnesses 60 kilometers away reported intense heat before any sound arrived. One man reported his shirt began to catch fire before he heard anything. The heat arrived at the speed of light, the sound came much later. That delay between the flash and the sound is the most important thing to understand. Light travels at 300,000 kilometers per second. Sound travels at less than half a kilometer per second. Sound is almost 1,000,000 times slower. At 100 kilometers away, sound takes 5 full minutes to arrive. Over Chelyabinsk, the shockwave arrived 2 minutes and 20 seconds after the flash. During that silence, thousands of people walked to windows to see what had happened. They filmed it. They posted about it. Then the shockwave arrived, and the glass came with it. The gap between the flash and the boom is the most dangerous moment of any impact event. The instinct is to look. Moving away from windows is what actually keeps you safe. Not every meteor explodes in the atmosphere before reaching the ground. Stony rocks under about 25 meters almost never make it through. Iron meteorites are different. A 10-meter iron meteoroid can punch straight through and leave an actual crater. The same size stony rock would explode long before it got there. After slowing down to a few hundred kilometers per hour, the glow stops. The fragment falls silently and invisibly. This is called dark flight. A freshly fallen meteorite is usually just warm, sometimes with frost on the inside. Space is near absolute zero. The heat never had time to reach the core. The Hiroshima bomb released about 15 kilotons of energy. Chelyabinsk released 500 kilotons from a 20-meter rock. Tunguska released 10 to 15,000 kilotons. The Chelyabinsk object came from the direction of the sun. Ground telescopes can't watch the daytime sky. That's a fundamental blind spot. We've cataloged about 95% of asteroids larger than 1 kilometer. For objects under 140 meters, the detection rate drops to roughly 40%. For 20-meter objects, the Chelyabinsk class, it's below 1%. In 2022, NASA crashed a spacecraft into asteroid Dimorphos on purpose. The asteroid's orbit changed by 33 minutes. For the first time ever, humans had altered the path of a celestial object. Every day, Earth's atmosphere burns up dozens of incoming rocks. Most are tiny. The atmosphere handles them without you ever knowing. The same process that injured people in Chelyabinsk protects you daily. For billions of years, life on Earth had no say in any of this. Whatever made it through the atmosphere hit. That equation hasn't changed. The rocks are still out there. What's changed is that we're the first species who understand this well enough to see it coming. That's not a small thing. See you in the next one.